Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera to everyone. So this is the soil mechanic modules from Department of Geotechnics and Transportation, School of Civil Engineering. This module is prepared for the first year students. Under topic of soil compactions. Under topic of the soil compaction. So I'm going to divide the lecture into maybe two parts. So this is going to be the first part. So this is going to be the first part. As usual, each topic there will be an objective where we assume that students will able to have a comprehensive understanding on certain things associated to that topic. So for this topic, what I wish you to have in the end of this class, I hope that every one of you can identify the main parameters of compaction. So definitely you need to know the first thing you have to know what is the process. Process of the compactions. Process of compactions. What been applied. And then how to analyze and figure out what are the main parameters. And then we are moving to identify the factors that will affect the compaction process. It means that what are the external or internal factors that might affect the value of the compactions, the parameters of the compactions. And finally, you will understand how soil is compacted based on the specific engineering standards. So we are going to discuss on the testings to be carried out at field and also at lab. But for the first part, we emphasize first on the laboratory testing. On the laboratory. So we are going to discuss on some standards based on British standards or any other standards related to compaction tests. And later we are moving to the field testing. So let's start with understand what is actually compaction and why is compaction is important in engineering and engineering construction. And the answer is compaction is one of the construction stages. One of the construction stage. Mean that it will carry out as an initial stage. They take place and being practiced on every construction project, which means that initially what you need to do is you have to compact the soil, the area of your construction. So that why, because you want to make sure that that area will be stable after prior construct any geotechnical structure. So let's say this is your soil skeleton. The soil skeleton at the area prior compaction. So this is before you carry out compaction. Before you carry out compaction. So if you look at here, we have a solid here. This one represents solid, and the blue color here is water. And you also have the red color here is represent as air. Is air. So what is this? This three is the components of soil. We already learned this one. We already learned this one in soil composition, in which that the soil consists of three components: air and water, as a void components, and also solid. So before compaction, we know that in unsaturated conditions, your soil consists of these three components. You have air and water as the components of your void, and also solid. This is before compactions. This is before compaction. Alright, so this is your intention structure. Let's say this is your intention structure to be built on the ground surface. If you are not properly compact, if not compacted, if you are not compact your soil prior putting this structure, what happen? The structure may collapse. Okay, the structure may collapse. Okay, may collapse because of why? When you put structure, it means the structure is your load. Okay, the structure is your loads. So it will give the pressure to the soil beneath it. It will give the pressure to the soil beneath it. So as you apply the load, okay, there's a dissipation of pore water pressure. So there's a dissipation of pore water pressure. Okay, which means that the volume will be changed. Okay, volume will change. So with volume change, it means that in this case there's a compression. Okay, there's compression. So it means that, let's say this is your initial level. Okay, it might change to a certain level. So this happen if you are not properly compact your area. Okay, but if, let's say, you compact the area, okay, you compact the area, okay, this is your solid particles, right? So this is your solid particles, okay, and this is your water. Okay, when you compact the soil, can you see this is the initial condition, right? This is initial conditions. What happens? You increase more solid particle. You increase more solid particle, therefore, okay, your sample, or not, sorry, not sample, your ground that initially in loose condition, so this is what we call as a loose condition, okay, will change to a dense condition, okay, which make, okay, your soil become much more stable, therefore it will make sure also that whatever structure on top of that will be safe. Okay, and again, if you look at here, okay, after compaction, and try to compare after and before here, okay, after and before, okay, this is before, this is after, right? After compaction. This one is not being compacted, but you put the structure on top of that. So if you look at here, before compaction, you have everything. You have solid, you have water, and you also have air. But after compaction, there's only two components left here, only solid and also water. So what happens to air? Okay, all right, this is what you have to know. Okay, when you do a compactions, okay, when you do compactions, when you carry out compaction, the components that you want to remove is air. So you're going to remove air. Okay, so you're going to remove air as much as possible, and the spaces that initially been occupied by air now will be filled up by or replaced by solid particles, the new solid particles. Okay, the air that has been removed, okay, that area or the space that initially occupied by air is now being replaced by solid particle. Okay, so that's the reason why you will see that it will not change the level, it will not change the initial level. So you are going to top up, okay, the solid particle until it reach the initial level. So what are the advantage of doing a compactions? Okay, so the concept of compaction in constructions of highway, embankments, earth dams, and many other engineering structures is to ensure that the loose soil is compacted, okay, to become a dense soil. It means that this is the terminology that we have. The first thing that you want to change is you want to change any loose particles become dense. Okay, become dense. Okay, in such cases, it will increase their density. So it will increase their density. So you got with this changes, it will increase the density. Why increase the density? Okay, if you still remember, what's the density? Density, if talking about total, it means that total weight divided by total volume. Okay, I'm talking about density. This is not density. Okay. So when you're talking about total weight, you have weight of water plus weight of solid, right? Okay, so remember, okay, if this is your soil element, initially you have air, water, and solid. Okay, after compactions, okay, solid is still there. With additions of water also, okay, these spaces that originally occupied by air now been replaced by solid. So the weight of solid here will be increased, therefore the density also increase. Okay, once the density increase, okay, it will also increase the shear strength. Okay, how? Okay, this is the equation for shear strength. You have C, normal stress, tangent, V. Okay, so look at this one. Okay, stress is equal to unit weight times step. Okay, so you increase unit weights, or in this example, it means that you are using the density lah. Okay, the density. So if the density is increased, okay, unit weight increase, definitely the stress also increase. With the stress increase, which means that the strength also increase. Okay, and it also reduce the compressibility. Okay, definitely it will reduce the compressibility because you already changed, okay, loose to dense. Okay, and it will reduce also the permeability. Yes, it is also correct. Okay, let's say this is your initial conditions where the soil in loose, right? In loose condition. So when you compact, remember when you compact, okay, you compact, it means that you remove air. Okay, that's the first thing. Okay, the components that have been removed is air. You remove air and you replace this air with solid. Okay, so replace with solid. So you replace it with more solid. Okay, so let's say you have more solids here. So now it become dense. Okay, so initially before you have these solids, okay, before you have all these solids, okay, the water can be easily, okay, flow through the solid particles because your sample is in loose conditions. But when you compact, okay, you remove air, you replace with solid, so you have more solids here. So it makes water become difficult to flow within the solid particles. So it reduces the permeability. Okay, what is the permeability? Is the ability of water to flow through solid particle. If it's easy, it means that your K value is high. If it's very hard for water to flow, difficult for water to flow, which means that your K value will be low. Okay. Okay. So that, okay, once you achieve everything here, okay, let's say you already achieved everything here, okay, will make your structure that been built on top of a ground surface that has been compacted more stable and durable. It means that durable, you're talking about long-term effects. And definitely, okay, it will reduce the liquefaction potential. Okay, what is the liquefaction? Is the post-earthquake phenomena, right? Post-earthquake phenomena. It happens, okay, for loose soil. So now when you compact, okay, you already change this loose to dense, so it will reduce, it will minimize. Okay, you cannot eliminate, okay, but at least you can control it. Okay. Okay, let's discuss on the compaction process. Okay, let's say this is your initial conditions. So this is before compactions. Okay, if you look at the next figure, okay, you have to apply loads. Okay, you apply load. So the compaction process will not be happen if you are not applying any load. Okay, you cannot just hembus. Okay, you have to apply something on top of that so that you will push, okay, the air to be removed. Okay, because you want to remove this one, you want to remove as much as possible. But in order for you to achieve, okay, to achieve the main of the compaction process, which is remove the as much as possible air, okay, you need a help. You need a help from water. Okay, you need a help from water. So water will act as a lubricant agent, okay, just to facilitate, okay, the rearranging of solid particles, okay, to become a dense packed structure. So it means that you need to add water. So definitely, okay, the weight of water or mass of water also increase at certain point because you need to add certain amounts of water. Okay, initially your soil definitely has a moisture. Okay, for unsaturated condition, it has its own moisture, but you need to add more water to helps you to remove air. So water, remember, is only a helper. Okay, you apply load, okay, you remove air with the help of water because water is the one that will helps to arrange back the particles so that the particles will be moved to a bottom part and become dense. Okay, so you apply more loads. Okay, you apply more loads, you remove more air. Okay, you apply more loads, you remove more air. Okay, so these empty spaces, okay, when you remove this empty space will be replaced by solid here, by solid. So there's additional of solid here. Okay, additional. Okay, you keep apply load until, okay, all air been removed. Okay, all air been removed. Okay, so all those empty space will then is occupied by solid particle. Okay, will then occupied by solid particle. Okay, let's go with particle. So therefore, if you look at here, the mass of solid will be increased. Okay, this is the initially this is your mass of solid. Okay, after compaction, okay, at certain specific energy, the mass of solid will be increased. Okay, the mass of solid will be increased. Okay, compaction is process, and the compaction definitely has to be proceed. Okay, need to be proceed until most of the air portion is replaced by solid particle as much as possible. Okay, this is achieved when the water added is at optimum moisture content or optimal water content. Okay, so remember, when you apply load, okay, you need a helps from water. You need a helps from water. So you will continue or proceed the compaction until all air has been removed and that empty spaces will be replaced by solid particles. So this is only happens, okay, at the optimum moisture content. Optimum moisture content. So it means that you have to know what is the optimum amounts of water to be added in order for you to achieve this condition. Okay, so what is the optimum water content? So optimum water content, okay, is the highest it's not highest water content, is the optimum water content to achieve the highest density possible. Okay, because you aim to make sure that the mass of solid increase so that the density will be increased. Okay, mass over volume, so mass of solid increase, okay, the density also increase. So you want to achieve the highest possible density. So you want to get the maximum or the highest density as possible as you can at optimum moisture content. So here are the main parameters that we are looking for. Okay, we discuss first on the process. Okay, as we discussed in previous slide, it's actually the same thing. Okay, if you refer to this graph, okay, this is the graph of density versus moisture content. So from here you already know what are the parameters to be obtained from compaction, right? So you know that you have to get the dry density and also water content. Okay, if you look at this graph, can you see that the dry density here, the dry density after compaction first increase. Okay, increase. The same thing also, moisture content also increase. So the dry density after compaction first increase as the moisture content increase, So when the moisture content is gradually increased, you increase more moisture content and at the same compaction effort, the dry density also keep increase. Okay, but up to a certain moisture content, let's say beyond certain moisture content, okay, exceed this one, okay, let's say you exceed it, okay, you will see that any increase in moisture content, okay, will tend to reduce the density. Okay, tend to reduce the density. Okay, tend to reduce the density. So this phenomena happens because of what? Okay, it happened because the water takes up the spaces that would have been occupied by solid particles. Okay, remember your aim is to make sure that you remove air. Okay, you want to remove as much as possible air. You want to remove air, and these empty spaces, okay, that initially, okay, occupied by air, replaced by solid particle. Okay, you replace it with solid particle, okay, with the help of water. With the help of water, so definitely what amounts of water also keep increase. But up to a certain point, okay, even though you add more water, this it has been replaced by solid. Okay, now you are tends to remove this solid, and instead of solid that been occupied, okay, at the empty spaces, now water take over. So that's the reason why water content increase but the density reduce. What kind of density that reduce? We're talking about dry density, because what is the dry density? Mass of solid divided by volume. So initially supposedly we have higher mass of solid, but now, okay, the mass of solid might be reduced because here you have mass of water. So mass of solid reduced, that's the reason why dry density also reduce, okay, up to a certain moisture content. Okay, we are not talking about bulk density, saturated density, you're talking about dry density. Okay, if you're talking about total density or bulk density, yes, okay, you don't have any problems on that. Okay, because of what? Okay, if let's say the mass of solid reduced but that spaces been occupied by water, so what mass of water increase, so will not affected the bulk density. But now you are talking about dry. You're talking about dry, mass of solid divided volume. Okay, look at the graph. This graph, okay, for y-axis denote for dry, not bulk. So now we're talking about bulk, dry. Okay, the dry density reduced because of why? The mass of solid reduced, because supposedly initially, okay, the empty spaces, okay, that initially air, okay, for air, but because you did a compaction, you remove air, so you want to replace by solid. Okay, initially definitely the mass of solid will be increased, but now, okay, you put more water, so you have a tendency to remove the solid and replace it with water. So the mass of solid here will be reduced. That's the reason why the dry density also reduce. Okay, so what you are looking for is the maximum dry density corresponding to its optimum moisture content. This is what you are looking for. You are looking for maximum dry density and optimum moisture content. So the two parameters, okay, two main parameters of compaction is maximum dry density corresponding to its optimum moisture content. Okay, so here is the regions why the dry density increase, and here is the regions why the dry density will reduce. So it means that the optimum moisture content, okay, plays an important role. Okay, it is a boundary, okay, of where the dry density will be increased, and another part is the area for when dry density is reduced. So optimum moisture content separates those two regions, right? So the soil compactions parameters are both obtained from lab testing, okay, based on the guideline, okay, and also you have field testing. So all those compaction parameters can be obtained from lab and also from field. But okay, what you need to know is, okay, if you have an area to be compacted, okay, you take the sample first. You take the sample at the area before compactions. Okay, you take the sample at the area that you want to compact. Okay, bring back to the laboratory and you do a compaction test. You do a compaction test, you got the compaction parameters. What are the compaction parameters? The MDD and OMC. So this MDD and OMC from lab testing will be your guidelines, okay, in order for you to achieve a desired compactions at field. So what you need to do is to get the compaction characteristic at lab first and then make it as a guideline for you to achieve whatever compaction characteristic at field. Okay, I think we stop it here first. Okay, later we'll continue with the discussions on the laboratory testing and also followed by the field testing and other factors that were affecting the compaction process. Okay, with that, thank you very much.